Good morning, student. Okay, today we are going to discuss about the three-dimensional packing arrangements, the hexagonal and the face-centered cubic arrangements. This hexagonal and face-centered cubic arrangements involves the formation of three layers: formation of first layers, formation of second layers, formation of third layers. Now let us see the formation of first layers. The first layers is formed by arranging the spheres in the case of two-dimensional AB arrangements. So in the AB arrangement, the second row fit into the depression of the first row. Here we can see this is the A type arrangements. This is the first row. This is the second row. We fit the second row in the depression of the first row. In the depression of the first row, and same as the third row is same as the first row, and the fourth row is same as the second row. So in this way we arrange the AB. This is AB arrangements. This is the formation of first layers. This is the formation of first layers. So now let us see the formation of second layers. So in the first layers, there are two type of wires are formed. There are two type of wires are formed in the first layers. We place the second layer in the depression of the first layers. So there are two type of wires are formed here. You can see, so it looks like a triangle. Then another one, you look like a inverted triangles. Okay, there are two type of wires are formed in first row. There are two type of wires are formed. Okay, by placing the second row in the depression of the first row, there are two type of wires are formed. So in which one wire, okay, in which the apex is upward direction, another one the apex is downward directions. So in which the apex is upward direction, it is designated as a X. So in which the apex is downward direction, it is designated as a Y. Wires is nothing but it is a gap or holes or free space between the spheres or atoms. Okay, so during this formation of two type of wires, tetrahedral wires and octahedral wires are formed. Octahedral wires and tetrahedral wires are formed. Here we place the sphere. We place the sphere of the second layer over the first layers in the void of the X. In the void of the X. Okay, here you can see the apex is upward directions. This is we designated as a X. Here the apex is upward direction. Okay, this is a layer A. We place the second layer over the top of the first layers. There is some gap or holes or voids between these four spheres or four atoms. Okay, here you can see there is some gap or empty space or free space here. Okay, this voids is called a tetrahedral voids. Okay, here this is the layer A. We place the layer B over the on the top of the layer A. There is some gap or free space. It is called tetrahedral voids. Tetrahedral voids nothing but it consists of four spheres. So when we connect this center of these four spheres, we get a tetrahedron. Okay, like this we get a tetrahedron. Here the face between four spheres is called tetrahedral voids. So when we connect the center of the four spheres, we get a tetrahedron. So it is called a tetrahedral voids. Now in the first layers there is a apex in which there is a voids in which the apex is downward directions. So in which the apex is downward directions, we place the spheres of the first layers. Okay, here we are taking this the layer A. Here in which the apex is downward direction. Okay, the apex is downward direction. It is designated as a y wires. Okay, this is the layer A. We place the layer B by partially covering the void y. By partially covering the void y. So in this way. So nothing but we place the second layer in the depression of the first layers. Okay, it forms a octahedral voids. It forms a octahedral voids. It forms a octahedral. There is some gap or free space between these 6 spheres or 6 atoms. So this void is called a octahedral voids. This is a layer A. This layer A. So in which the apex is downward directions. We place the layer B by partially covering the void y. Now octahedral voids are formed. Octahedral voids are formed. It is nothing but it consists of 6 spheres. It consists of 6 spheres. When we connect the center of 6 spheres, we get a octahedron. We get a octahedron. So when we connect the center of this 6 spheres, we get a octahedron. So in this way, we get a octahedron. Now let us see the formation of third layer. The formation of third layer we can obtain by arranging the spheres in 2 ways. One is the AAA, one is the ABA arrangements. It is called the HCP structures. Another one ABC arrangement. It is CCP structures, CCP or FCC structures. So in HCP structures, by placing the spheres, here we place the third layer as same as the first layers. So this arrangement is called ABA arrangement, or we can say hexagonal close packed arrangements. So in this arrangement, the tetrahedral voids of second layer are covered by the space of the third layers. Here this is the we get, okay, we taking this, okay, this is a layer A. We place the second layer in the depression of the first layers. The third layer is directly sit over the first layers. Okay, it is a directly sit or directly fit on the top of the first layers. Okay, so in this way we get a hexagonal close packed structure. The first layer and the third layer exactly same. Okay, exactly same, but in the second layer is a different from the first layers and the third layers. So this type of arrangement is called a HCP, hexagonal close packing arrangements. Hexagonal close packing arrangements. So in another way, by placing the third layers, by covering the octahedral voids of second layers, it gives the CCP structures. This is the layer A. We place the second layer, then place the third layers, then we place the fourth layers. Here the fourth layer is exactly same as the first layers. So in this way it gives the CCP structure. Here this is a A layer, this is a B, this is a C, and this is again A. Here the A layer is exactly same as the fourth layer. The B layer and C layer are different from these A layers. Okay, this type of arrangement is called the close packed arrangements, cubic close packed arrangements. So the coordination number of this both HCP and CCP, coordination number of this both HCP and CCP is 12. Coordination number of this HCP and CCP arrangement is 12. 6 pairs in its own layer and 3 layer in the above and 3 pairs in the layer above, 3 pairs in the layer below. This is the most efficient packing. This is the HCP and CCP is the most efficient packing. Here we can see the coordination number. Here 6 pairs in its own layer and 3 pairs in the layer above and 3 pairs, we can say 3 pairs in the we take this, okay, the 6 pairs in the in its own layer, 3 pairs in the layer above and 3 pairs in the layer below. So in this way the coordination number of each pair is 12. Okay, the coordination number of each pair is 12 in both HCP and CCP. Here in HCP and CCP the packing efficiency is 74%. Packing efficiency is how much? 74%. Packing efficiency is 74%. In CCP and HCP the packing efficiency is 74%. Here you can see that this is the layer A. For HCP this is layer A, the layer B, this is the layer A. It gives like the hexagonal structures. In CCP layer A, layer B, layer C and again layer A. This is the CCP arrangement. Okay, cubic close packed arrangements. Thank you student, you understand how the HCP and CCP packing arrangements are formed. I hope you understand. Okay, this is very important. Thank you student.